Now we'll solve another Vogel's approximation problem. Actually, this will be a tie problem, how to solve Vogel's approximation problem in case of tie. So this is also Vogel's approximation method. This will be in case of tie. In that case, say our destination and source are given. Source are A, B, and C. Destinations are 1, 2, 3, and 4. The matrix, the cost matrix are given. The cost matrix are 3, 8, 7, 4. For B2 1, that is 1, B2 2 is 7, B2 3 is 5, B2 4 is 9, C2 1 is 8, C2 2 is 4, C2 3 is 3, and C2 4 is 2. These values are given. Say for example, the unit costs are given, and our supply product are 30, 40, and 50, and demand are 25, 35, 40, and 20. So as of previous solution for Vogel's approximation, firstly we have to calculate the penalties. Firstly write the matrix 1, 7, 5, 9, 8, 4, 3, 2, and our supply are 30, 40, 50, demand are 25, 35, 40, and 20. Now we have to calculate the penalties. In the row wise, the minimum values are 3 and 4, so it is 1. The minimum values are 1 and 5, it is 4. In the row wise, the minimum value as 2 is 3, so it is also 1. The penalties in the column wise, the minimum value is 3 and 1, the difference is 2. Minimum value is 7 and 4, it is 3. Minimum value is 5 and 3, it is 2. Minimum value is 4 and 2, it is 2. So the maximum penalty is here. So maximum penalty is 4. So we have to assign this value to the lowest cost. Our lowest cost is 1. So if we go to here to assign the 40, we cannot actually assign the 40 value here, because along the column the minimum value is 25. So we have to assign 25 here. So this column become exhausted, and 25 become 25 minus 25, that is 0, and 40 become 40 minus 25, that is 15. In the next step, our matrix become 8, 7, 4, 7, 5, 9, 4, 3, 2. This will be our matrix, and here the values are supplies are 30, 15. Now it's become 15 because we have already subtract the value 50, and lastly our demand will be 35, 40, and 20. And again we have to calculate the penalties row wise and also in the column wise. The row wise penalties are here 3, 2, 1. 1 becomes 3 minus 2 is 1, 7 minus 5 is 2. And in the column wise, 7 minus 4 is 3, 5 minus 3 is 2. In this column, the lowest values are 4 and 2. The minus of 4 and 2, the difference of 4 and 2 is 2. Here we have two values, actually two highest penalty. One is 3 and another one is also 3 if we look carefully. And within that, if it is try, since it is try, we have to look at the lowest cost. In this column lowest cost is 4, and in this row lowest cost is 4. Both are equal. So if any lowest cost is low, in that case we have to consider that case. Since this also tie, we have to look at the demand, maximum demand. Here maximum demand or supply. Here supply is demand is 35 and here supply is 30. So within this the larger one is 30. So you have to go for this. You have to assign 35 here. If we assign 35 here, so this column become exhausted, so it becomes 35 minus 35, that is 0. If we assign 35 here, the row become 50 minus 35, that is 15. So now our cost matrix become 7 4 5 9 3 2, and our demand are 40 20, and our supplies are 30 15, and it is also calculated as 15. Again we have to calculate the penalties in row wise and column wise. Here the row wise penalties is 3 4 1. Here column wise penalties, the lowest value are 5 and 3, so difference is 2. Lowest value is 4 and 2, difference is 2. Now the largest one is 4, so we will assign 15, this 15 value to the lowest unit cost. We can assign 15 here. Since this is less than 40, so 40 minus 15 become 25, and this become 15 minus 15 equal to 0. So our this row is exhausted. In that case, now our cost matrix becomes 7 4 3 2, and the values are 30 15 25 and 20. Now also we have to calculate the penalties. 7 minus 4, that is 3, 3 minus 2, that is 1, 3 minus 4, that is 4, 4 minus 2, that is 2. So highest penalty is 4, so we have to assign 25 to the lowest value. If we want to assign 25 to the 3, we cannot assign that because 15 is the lowest, so we have to assign the 15 value here. So this row become exhausted. 15 minus 15 become 0, and 25 minus 15 become 10. So in the next step we have remaining values, that is 7 and 4, and the values supply is 30 and demand already become 25 minus 15, that is 10, and this is 20. So we can assign 10 to 7 and 20 to 4. So total minimum transportation cost will be, firstly take 1 unit to 25 product, 4 unit to 35 product, plus 5 unit to 15 product, 3 unit to again 15 product, 7 unit to 10 product, and 10 unit cost to 20 product. So summing up all this, we get 435 BDT. This is the minimum cost we calculated using Vogel's approximation. Only complexity here is there is a tie case. In tie case, firstly we have to consider if it is tie, we have to check 3 situations. We have to check lowest cost. If lowest cost, we have to go to the lowest cost. If then we have to consider if the costs are same. In that case, we have to check the highest demand. So that's it. Here the tie problem, we can solve this. We have to check lowest costs are 4 4 same. In that case, we have to check the highest demand or supply. Here 35 is greater than 30, so we have to assign the 35 value here. So this is the Vogel's approximation problem using in case of tie. And only thing is missing here, actually at the beginning we have to calculate the summation of supply, that is 30 40 and 50, which is 120, and summation of demand, which is 25 35 40 and 20, which is also 120. So we have to write summation of supply equal to summation of demand. So it is a balanced transportation problem. So we can solve this using this method of Vogel's approximation. So we cover all three methods: the northwest corner rule, least cost method, and Vogel approximation. Hope you understand the whole all of this method. Thank you so much.